Good afternoon, my YouTube viewers. It's Crystal here. I'm just here this afternoon because I wanted to make another video. This video that I wanted to make is on paired design, which is an experimental design. So paired design measures the same experimental unit twice or in matched pairs, so each unit acts as its own control. This eliminates huge amounts of variability and makes treatment effects easier to detect. A design is paired when observations come in natural pairs, such as before versus after, left versus right, two conditions applied to the same unit, and matched office. The key is that the two measurements are not independent as they belong together. So what we're going to do is we're going to review the code of an example of a paired design. So the null hypothesis is going to be no significant difference, and the alternate hypothesis is going to be a significant difference. So the first thing we're going to do is we're going to create this paired design of a before and after experiment. So the first thing we're going to do in that regard is we're going to set our seed. The reason why you set your seed is so that every time you run the program, the variables are going to initialize to the same values. So you type set.seed brackets 3, and you can type any number you want into the brackets. So we're going to simulate the paired data now. So n, which is going to be your number of samples, is 20. So before is going to be a randomly sampled normal distribution of 20 samples with a mean of 72 and a standard deviation of 5. So that's going to be your baseline measurement. Improvement becomes a randomly sampled normal distribution of 20 samples with a mean of 4 and a standard distribution of 2. So that's your treatment effect. So after becomes before minus improvement. So we're going to put the data into a data frame. So df becomes data.frame brackets subject equals 1 to n. So that's going to be 1 to 20. After equals after. Difference equals after minus before. So now what we're going to do is we're going to perform the paired test, which is going to be a t-test. So test becomes t.test brackets df $ before, comma, df $ after, comma, paired equals true. And then we're going to run the test. So when we run the test, the paired t-test, your data is ds $ before and ds $ afterward. So your t is 10.354. Your degree of freedom is 19. Your degree of freedom is calculated by taking the number of samples, 20, and subtracting 1, giving you 19. And so your p-value is 2.988 to the negative 9th. So your p-value is going to be lower than your significance level of 0.05, and since it's lower than 0.05, that means that you're going to reject the null hypothesis in favor of the alternate hypothesis. So the alternate hypothesis is true mean differences is not equal to 0. And that's letting you know that there is a significant difference between before and after. So the 95% confidence interval is 3.27 to 4.93, and the sample estimates, you have a mean difference of 4.1. So now what we're going to do is we're going to plot our paired design. Each subject is a line connecting before to after. So plot brackets, and it's going to be a vector from 1 to 2, a vector of 1 and 2. A range is going to be a vector from df $ before and df $ afterwards. After, type equals n, xaxt equals n, xlab is the label on your x-axis, is condition, and ylab is the label on the y-axis, is score. Main is your title, is paired design before versus after. And then we're going to put an axis in there. So axis brackets 1 comma at is a vector of 1 and 2. Labels is a vector of before and after. And we're going to draw lines for each subject. So for I in 1 to n, and so n is 20, so that means for I in 1 to 20, lines, you're going to put some lines in there in this for loop that you're creating. Lines brackets, a vector of 1 and 2, and then another vector of df $ before I, comma df $ after I, and then the color is gray 70. And then we're going to add points. Points brackets wrap, that's a repeated vector, brackets 1 comma n, and so n is 20, comma df $ before, comma pch, that's the size of the dot, is 19, and color is blue. And then we add some more points. Points brackets rep, that's a repetition vector, brackets 2 comma n is 20, n is 20, comma df $ after, comma pch equals 19, comma color equals red. And then so we run the program, and when you run the program, this is what you come up with: a paired design before versus after. So you've gotten your means for each sample with your before, and then you've got your means for each sample for after. So you can see that the means for each sample of after are lower than the means for each sample before. And so let's just go back and look at our sample data. So before is going to be a mean of 72, and improvement is going to be a mean of 4, and so after becomes before minus improvement. So that means 72 minus 4 is 68. So 72 minus 4 is 68. So this sample data that we have made, we have designed it so that the mean of the after is less than the mean of before. But this is just a simulation to show you how the paired test works. So that concludes this demonstration, and that concludes this video. The next video is going to be on another statistical subject, so I hope you decide to watch the next video, and I hope that you got some meaning out of this video. Goodbye.